Welcome everybody to episode 24 of Games with Go, where we are going to start getting input and moving our player around the world or through the dungeon. So last episode we got everything rendering. And now we want to be able to take key presses and move the player through this world. So at the moment we've got this UI interface. And last time I was thinking of having it always draw and then get input. But I think I'm actually going to separate that out. And the reason for that is I realize we might sometimes want to have the game tell the UI to draw multiple updates before we get any more input. For instance, if someone were to click on the map with their mouse somewhere, like say you were here and you wanted to click here, the game might figure out a fastest path to get there and then update the game one step at a time. So you see the player move from here to here, and we don't want to wait for any input in between those two things. So we can do that by pulling out the draw and get input into separate functions. So we might do it like that. I think that's all we need. And then for our input struct, we're not going to have a bunch of booleans. We're going to have a input type enum. So the input could be for now we'll just do up, down, left, and right. And for now, all the input struct's going to contain is a single input type. Now later on, we're also going to have stuff like mouse click is one of the types. And when that's the type, we'll also want to have like an XY to go along with this. And for now, we'll just do keyboard, keep it simple, make sure everything works the way we hope it will. So when we call get input on the UI, it's going to give us back either up, down, left, right, and that's it. Okay. So our game loop now is going to draw the level, and then get input. And then we'll use that to update the state of our level eventually. Okay, so now to get input, we move to our UI file. And we need to add a bunch of stuff to this loop. Well, no, this is just a draw loop. So this can stay. Take out this delay. It's not going to return an input anymore. So now we'll have a get input function. And we'll have that return a pointer to an input. So let's change that. Oh, we already did that. Good. Okay. So now to do to get input in SDL, we can refer to one of our old projects, and I'll recap in case people weren't here for that. Let's do a new window. want balloons too. So our balloon project is one where we had a whole input loop. So this is the key code we want right here. So I'm going to copy and paste that. Okay, so what we've got is in SDL you can poll for events, and you do that right here. So we get an event, set it equal to poll event. As long as there is one, we keep going. Once it's nil, we quit. And then we check what the event type is. And for instance, quit event would be if you clicked the little X at the top of the window. That's a click event for quit. And we can get touch events, which we're not going to do right now. And in fact, one thing we could do real quick is let's go back to here. Let's make a quit as one of our inputs. And we can use that real quick to do some testing. So input type, then we'll quit. So this would be return game.quit. Oh, the input with a game.quit. Let's see. Unknown field type. Why not? Oh, this has to be capital or it's not exported. So we couldn't see it from this package because it was lowercase, and lowercase fields are not exported. Okay, so if we get the quit event, we'll return that. And then this should break out of the loop and quit the program entirely. So let's give it a try. Input type undefined. Uh, 130. Okay. Uh, 156. Oh, this should be game.input. So that's one tricky thing about Go is if you're kind of experimenting, the unused variables being a compiler error can be pretty annoying. Okay, what happened? 130. Oh, did we get back a null? Okay. Yeah, so we're returning null if we didn't get any events. So first, need to say if input is not equal to nil, and the type's not equal to quit, then return. Otherwise, keep going. Okay, so now we're good. Hit X, closes it. Okay, so the basic framework works, but now we got to get keyboard events. So let's see how these work. So keysims and SDL. Let's look up how these work. So I think we need to look at key codes. Which start with SDLK, and I think there's an up. Let's see. So to test this, I'm just going to do a quick printf debugging. All right, so that works, but you get lots of ups. So I was trying something new. If you were here for the balloons episode, we used the key state array, and I think we're still going to have to do that. I was hoping that this would give you like a key press event, and it's not. You're just getting all of them. I don't see any way to not do it that way. So we're not going to use this for key presses. And we don't need this E. So we're going to do the same thing we did. We did this with the balloons. We didn't have any keys. So we did it in evolving pictures. Here we go. So what we want to do is we want to keep track of the current keyboard state and the previous keyboard state all the time. So we're going to make this these are going to be things we set up actually when we initialize. So let's put this in init. And then we're going to predefine these. So these will both be slices of uint8s. And once we get this keyboard state, this is a pointer to a slice that SDL is managing. So this always gets updated. So all we have to do is update previous keyboard state after each loop. So we'll need to do this copy at the end here. And so now what we want to check, we want to say if keyboard state scan code up. So we check if up is not being pressed, but it was being pressed. Oh, this is a returns an integer. So if that is 0, then that is not 0. So now we get 1 up per key press. That's what we're after. So we're going to make our input which will be zeroed out. So basically we're going to copy the same logic for up, down, left, and right. Capital type. All right. I guess the other thing we want to do is we want to wrap this all in a loop. So we don't just want to check one time for input and return, I don't think. We want to wait. So we'll say if input, let's see, how should we do this? Let's make this a pointer. We'll just do it like this. So this way, the get input function will keep waiting for user input, and we won't be re-rendering the whole scene every time until they do. So now back here in the game, we can switch on input.type. We'll just test a couple cases. I'm going to put just a permanent format.println here, so I don't have to keep removing that include. Okay. Uh-oh, we're getting hundreds of ups and downs. And that is because we're not updating this when we return this early. What's the best way to do this? So this might not be the best way. This one I'm going to do for now is this is going to be none. So when we do an uninitialized input, this is going to be start out as none because that's going to be 0. And then we'll say if input.type not equal to none, return the input. Game done. There we go. All right, game's getting input from the UI. We can click the X. Next up is we need to do something with that input. So just the obvious thing we can do is just update the player position. All right, game's done. Let's ship it. Of course, it's got some problems. It lets us walk through walls and walk into the void, which doesn't get erased. That kind of lets us draw, though, and walk through doors. So I think first thing we should do is check to see if you're running into a wall and not let you go through. So let's handle that. Let's start handling this input in its own function rather than cluttering up the run function. So we will take a level and an input, and we'll return a new level. I guess really we will not be returning a new level. We will just be changing the level we got. if you're doing functional programming, you would actually return a new level, which can have some advantages, but it can be slow. So we're not going to do that. And we don't need to do that. All right. Okay, so we need to check if the place that the player is going to is available. So what's the best way to do that? We'll say if level player.y -1 or level.map you know, we can shorten our typing here. We'll say P is our player equals level.player. Then we can just say P.y so we could just check to see like if it's equal to stone wall, because right now that's all we have is stone wall, but there's also doors which you can't walk into if they're closed and so on. So we should probably make a function we'll call it can walk, and it will take a level and an X and a Y and return true or false. So we can say tile is equal to level.map yx. Just call this T. And switch on T. So case if it's a stone wall or door, because all our doors are closed right now. What are the other cases we have so far? Blank. Probably should not be able to walk in the void. Return false. Otherwise, return true. So now we can just say if can walk p.x p.y -1. We have to all right, then we can repeat that logic for down, where y is +1, left, where x is -1, and right. All right, so now we should be checking every direction to see if it's actually possible to move there. Super broken. What did I do wrong here? Y -1, y +1. Oh, there we go. Oh, we're getting through. Looks like the X checks are no good. Oh, we were not putting X in there and getting our tile. All right, excellent. Now we're trapped. So next up, we should make doors openable. So there's a couple different ways we could do that. It could be that just once you press into them, it'll open them if they're openable. Or we could have you like press O to open a door. Let's just have it that if you try to move into a door, it'll first open it, and then the second time you move into it, it'll actually open it. So let's see. And let's change this now to closed door. And we'll also have an open door. Maybe a slash for an open door. So we got to update this. Update our level loading code. Okay, so now then, if we can't walk, we want to check and see, was it a door? And if it was a door, we want to open it. So let's make something called check door. And this will just get that tile and check to see if it's a closed door. And if it is, make it an open door. Let's see, we need to pass in the exact same stuff. Okay, the last bit we have to do is we have to make our UI know about rendering open doors. So we said that would be the slash. So let's open up our tiles. So open door, I guess we can use this one. So let's see, that is 1644. Divided by 32, 51, 51, 1. Let's see how this goes. It went good, but it did not erase the old door. So what we should be doing here when we draw is our draw function. We should be saying, I think it's renderer.clear. Oh, that's no good. Why not? Oh. So I'm clearing after we're drawing all the tiles. All right. Now the door opens and we can step through. And one thing we could think about is maybe like the door should have the floor color of the tiles behind it. That might make sense. All right, so now we've got doors. And so far the only effect doors have is that they require an extra step. And that could be a gameplay thing, like if you're running from monsters and a door is closed. Takes you an extra turn to get away, takes them an extra turn to get through, and so on. But we'll also have locked doors eventually. Okay, so the next problem we have is we just leave the screen if we walk around. So there's a couple different ways to handle that kind of thing. One way is to always keep the map centered on the player. And if you've played a game like Pixel Dungeon, that's the way it works. Like you just move and the whole screen always moves with you. You can also have the screen stay where it is until you get to the edge, and then everything scrolls over. What I'd like to do is have kind of a hybrid of that, where you can move around a little bit without the map scrolling, and as you get sufficiently far from the center, it'll start moving with you. It just makes it feel like you can move around freely without the whole screen shifting around on you all the time. So let's give that a try. And so I guess that'll be entirely... should that be entirely up to the UI? Probably so. The game could control whether that's acceptable or not. So we're eventually going to have like fog here. Like you wouldn't be able to see this room when the doors are closed. And the game could control that by sending fogged out tiles to the UI. So the UI couldn't break the game by letting you see too far up or down or left or right, I don't think. So we'll let the UI decide how that scrolling of the screen works. So we want to keep track of where the center is. So let's see how we should do that. We'll have a center X and a center Y. We'll initialize these to -1 for now. I'm going to think if there's a better way to do this. It's always kind of a code smell if you're setting things negative to make them be uninitialized. So we'll think on that. And then here, when we first get a level, we'll say if okay, so this is going to be the center of where we draw from. So we want to put that coordinate in the middle of the screen. So how do we do that? We need to calculate an offset based on the width of the screen and the height of the screen. So we've got our width and height there. So if the player, for instance, were at 0, 0, then we would want to shift by half of the screen width. So I think that's right. And then when we draw, when we make our rectangles, oh, but this is these are 32 by 32 tiles. So let's go ahead and make this in 32 since it's always going to be used that way. So for our destination rectangle, we're going to apply these offsets. And it's going to be same for the player. Okay, that looks a little off. So let's play with it by always centering on the player. Okay, it's not moving enough. There we go. Okay, so that's keeping it always centered on the player. Which is better than doing nothing. Cool. So now let's try to make it only recenter if the player is far enough from the center of the screen. So let's do, we'll do a distance calculation. We'll say distance x is equal to distance y So do distance between 2 points. let's just try 5 out. So if we get more than 5 units out, 5 tiles from the center, then we'll reset the center. Okay, but that's not totally what I want either, because I don't want the whole thing to shift onto the player again. I just want to move it 1. So Last Shade 614 in chat asks, how is Go working out for games in my opinion? So this stream was originally intended, or is originally meant to be just a general programming education stream where we do things that are games mostly for fun. There are though some things about Go that's very good for games. The garbage collection is very low latency compared to Java or C#, which focus on throughput. So that helps reduce problems of garbage collection pauses that you might get if you're using Unity, for example. And it also compiles to native executables, which simplifies sharing your games with people or packaging them up for distribution, and can improve performance as well because you don't rely on a JIT to compile your code as it's run. But there are some downsides, which mostly revolve around the fact that the gaming ecosystem is not very big. If you want to make a game in Go, you'll mostly be making it from scratch like we are here. Whereas if you used C++ or C#, there's lots of engines to choose from, or other frameworks that aren't quite engines to choose from. So if you're wanting to make something from scratch, then Go has some really good points. And if you're wanting to use an engine, then there isn't really an engine for Go. So that summarizes my thoughts on it. Okay, so if our distance from the center is greater than 5, we just want to adjust by 1 rather than moving the center completely. So we need to see like which way it's off from the center. So maybe we don't want to do a distance calculation after all. Maybe we just want to do it like this. So we'll say if let's define a variable that will be like our limit. We'll say 5 for now. So if the player gets more than 5 units to the right of our center, then we'll increment the center. And if he gets 5 units to the left, then we'll shift our center to the left. Do the same thing for Y. All right, let's see if that gets the effect I'm looking for. Imported and not used math. Oh. So we imported math to do the distance calculation, which we're no longer using for square root. There we go. So that's kind of the look I was going for, that I like. But you're welcome to do whatever you want in your own UI. You can present the game however you want. All right, that's great. That was what I was hoping to get done today. So now that I think about it, we probably will want a command to open doors so that we can also have a command to close doors. So we'll think about that. We also need to think about maybe a better way to do this center X and Y. We're also building up a lot of global variables in the UI, so we might want to think about a way of refactoring this so we're not getting out of hand here. I guess those are the big things that need cleanup. All right, any questions about what we did today? Questions, concerns, ideas for things that we should implement next? So the plan currently for next episode is to do add some mouse click interface where you could be here, for example, and click here, and the game will figure out the optimum path to get from there to there, if there is one, and then take you there. So like if you're not wanting to press 1,000 times because you know you just want to go here and it's safe, you can click and it'll figure it out for you. And to do that, we're going to learn an algorithm called A-star search, which is a graph algorithm that's really, really common in games. Like game engines have it built in. It's that common. And it's a really good learning exercise. It's one of the cool graph algorithms that will find the shortest way to get from point A to B in a graph. And it may not look like it, but our grid is a graph. Every cell is a node with connections to the neighboring nodes that are not walls, for instance. So that's what's planned next. Any questions before I go? All right, everyone, good night.